Okay, so just a little refresher on what we're supposed to be doing with our parent functions. In 7.1 and 7.2, we spent a lot of time taking this chart and building out all of the points that we needed to have for those parent functions. When we're drawing the parent functions for a quiz or for a test, it's very similar to what we did in the fall, where I don't need you to be able to graph a zillion points in order for you to graph a complete parent function. So in reality, when in the notes, we graphed sine starting at 0, 0, and at pi over 6 was a half, and at pi over 2 was 1. And we graphed out all of those points to start with. When we do a parent functions quiz, we really don't need all of those points. In fact, the most important points for sine are going to be 0, 0, and pi over 2, 1 to get started. This tells us that the sine function starts at 0, 0, and it hits its maximum at pi over 2. And if you can remember anything about the basics of the Trig's values, you know the next important part would be the sine value at pi, which goes back to 0. Sine at 3 pi over 2, because it's at the bottom of the unit circle, goes down to negative 1. And sine of 2 pi goes back to 0. So if you can think through that real quickly with a chart, it gives you 5 basic points here. And then we just reverse those points to go back along the negative side to give us a complete sine picture. So if you follow that same kind of logic, then for cosine, the most important points are going to be the cosine of 0 is 1 and the cosine at pi over 2 is 0. This tells us that our cosine graph starts at its maximum of 1, hits a 0 at pi over 2, and then we can use what we know from our unit circle to remember the next important point would be cosine at pi is negative 1, cosine at 3 pi over 2 is 0, and cosine at 2 pi is back to 1. Then we can reflect over here to complete the graph on the negative side. So these parent functions should not be taking a ton of time to graph. Very quick, easy graphs. Tangent, our most important points are actually going to be 3 of them. At 0, it's 0. At pi over 4, it's 1. And at pi over 2, it's undefined. So this tells me when I graph my tangent function, I start at 0, 0. At pi over 4, it goes up to 1. And at pi over 2, it's an asymptote. So what you should do is then remind yourself that this means our asymptotes are at all the pi over 2's evenly spaced. And negative 3 pi over 2. It goes through 0, 0 in the middle, and if you remember, tangent makes that cubic shape. I know it goes up to the right because of that point at 1. Then, from there, I really only need you to graph the zeros in the middle and the asymptotes, and draw your S shapes going up and to the right for all of the tangent functions. Tangent branches, I should say. And as we talked about in the notes, as well as just parent functions from before, all of these blanks should be coming from just looking at the graph. I should be able to look at this and say the domain of this is all real numbers. The range is negative 1 to 1. The period of the function is how long it takes to complete one full cycle. So from here to here, where it starts repeating, is 2 pi. Remember the zeros we said were that special notation where we say we pick 1 0, like 0, and then say they occur every how often? They occur every plus or minus pi, and we put that constant k next to it to help us know that we can continue from 0 out pi, and then out another pi, and then out another pi, and so on as we go. Symmetry, your options are even or odd. Remember, even means that we would be able to reflect over the y-axis and have this point match right over here with a similar part of the graph. That's not there. That means this is an odd function. Whereas cosine is even because it matches directly across the y-axis if I drew that dotted line in. Tangent is, again, an odd function. Also, remember, one different thing about tangent is how we write its domain. Rather than saying from negative 3 pi over 2 to negative pi over 2, from negative pi over 2 to pi over 2, and so on in all the different ways, we say our domain is all real numbers, but x does not equal our asymptotes. And for our asymptotes, we use that special notation of there's an asymptote of pi over 2, and then there's another asymptote every pi, k, so we've got to leave them all out. For tangent, the period is only pi because it's only negative pi over 2 to pi over 2 to get one full picture. And our zeros, we use that same notation. Now, when we go to do the 3 reciprocals, I don't even use my chart anymore. So I go and I look at this and say, okay, if I was to take that and then do the reciprocals based off of the 3 originals, anywhere that sign has a 0, so here, 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 the reciprocal of 0, and these, reciprocal of 0 is undefined. So everywhere sign has a 0, cosecant is going to have an asymptote. So asymptotes everywhere sign equals 0. All right, so there's my asymptotes. Anywhere sign has a maximum of 1, the reciprocal of 1 is also 1. That tells us this is going to be where we have one of our upward facing u's. Anywhere sign has a minimum of -1, its reciprocal is also -1. This tells us this is where we're going to have our downward facing u's. And this is enough for us to graph our cosecant function. I would graph the secant function exactly the same way, except based off of the cosine. Anywhere the cosine has a 0, the secant is going to have an asymptote. Anywhere cosine has a maximum, the secant is going to have an upwards facing u. And anywhere it has a minimum, secant will have a downward facing u. If I use my cotangent or my tangent graph to get my cotangent function the same way, the 3 reciprocals should flow pretty easily from the 3 originals. So anywhere tangent has a 0, cotangent has an asymptote. Anywhere tangent has an asymptote, cotangent has a 0 because 0 is the reciprocal. And I could do the reciprocals of all the other points, or I could just remember cotangent goes backwards from tangent. And I can complete my graph that way. Again, all of the blanks on the side there should be filled out based off of the graph. Couple things to be sure of. Cosecant and secant do not have a full range of -infinity to infinity. We do the lower u is -infinity to -1, and the upper u is 1 to infinity. We must also do our domain where we leave out the asymptotes. So this one has an asymptote at 0, and then every pi after that, so pi k. Just like sine is odd, so is cosecant. Just like cosine is even, so is secant. Just like tangent is odd, so is cotangent. Also, please remember secant and cosecant have no zeros because they do not touch the x-axis at all. So ideally, hopefully this video showed you how you take your chart to get the basic points for sine, cosine, and tangent, and then take sine, cosine, and tangent to graph the 3 reciprocals.